Hello and welcome to this, the 10th video in my series, entitled An Absolute Relativity. And if you follow the sequence all the way through, the videos were designed to show how one simple idea led to the simplification of everything. If you follow them through, certainly in the last one you get more an idea why I've called it an absolute relativity. But this will be it's actually the last in the series describing how my idea and this theory of an absolute relativity simplifies everything in quantum and atomic physics. Just simplifies everything. And let me tell you something of how this came about. Some time ago, I was recovering from an injury, and I had time to sit and think and imagine. And I started to imagine what is really going on at a quantum level. I've always, quantum physics, I always like to say, you're never going to be able to understand this. If you think you understand it, then you really don't. I've been happy with all of that, and I was thinking all this through, and I held my hand up to an electric lamp, and of course my palm of my hand was illuminated by the lamp, and the closer I got to the lamp, the brighter the illumination, and further away the less illumination. And something occurred to me out of the blue, that the so-called photons that were supposedly landing on my hand had never left the lamp until they got to my hand. The atoms of the lamp are in direct contact with the atoms of my hand. And the more, the closer my hand got to the light source, the more atoms in the light source were in direct communication with my hand. And conversely, further away I got, the less were in direct communication with my hand. And this realization, I think, what does this mean? What's the significance of this? And so I started to look back at all of the way I had understood quantum mechanics, quantum physics, atomic physics, and apply this idea that photons, and then indeed every other subatomic particle, does not have independent existence. All we have is atom to atom communication. Direct atom to atom, single communication, one atom to one atom. That's it. When I then went back and looked at how all this applied, this is then why I produced this series of videos that show, that illustrate how this idea applies and simplifies everything. It is the simplest explanation of what's happening at a quantum level. And when I just said that this is the last in the series, it's the last in the series. I'm intending to do this. This takes the whole description and applies it to every aspect that I think proves that it has merit. But what I want to do, will produce more, appendix videos, if you like, that will look at different aspects that have come up as I've gone through. Now, what I did was then take my idea to, and please go back and have a look at the videos and see how this idea just tidies everything up. Looked at Young's double slit experiment. There is, as far as the photon is concerned, there is no distance between then and then. All we've done is we've reshaped the wave from each single atom to each single atom. Each single atom of the source, each single atom of the target, and thereby, because each atom is a wave function of energy, it's reshaped through here, and the particle, the particulate aspect of this is the particle response at the receiving atoms. There it is. There it is. You see, I've always been very uncomfortable with the idea of a massless particle that transfers mass, that transfers energy, which is mass. It doesn't make sense. This explanation then, look at it, it does. It simplifies everything. I went from there to explain what's happening in quantum entanglement. And again, all the mysteries of quantum entanglement are eliminated. Just for a second, go back to there. Another thing I just want to touch on is the idea that these particles, so-called particles that are floating around here, are in a superposition of states. In other words, they exist everywhere. And when we pin down one, say, photon, Everett's idea was that all of the other possibilities are realities in alternative universes. The many worlds theory. I cannot stand this. I cannot take this, that this is being taken seriously. Come on. We have one atom that is energized and it is responding to an atom over here is responding to the extra energy there. There's, as far as the photon is concerned, there is no distance between there and there. This is instantaneous. Many worlds theory. I'm going to come back to that in another appendix video. But as I say, I went on to explain how this applies to quantum entanglement and the mysteries involved in quantum entanglement. And when we look at it in this description, the whole thing is simplified and there are no mysteries. And then I looked at the photoelectric effect. This was the phenomenon for which Einstein won his Nobel Prize, which is absolute travesty that he won it for this and not relativity, but there you are. And when again, look at the video, and the explanation of what's happening becomes obvious that it's going to behave like this. There's no mystery. If we use my description, there is no mystery. Then I looked at photons and electrons, and was able to describe complex atoms, not with a nucleus with electrons flying around them, but a pattern of protons and neutrons. And a neutron itself is a proton at a different energy. If you take, as I say in the video, you take a neutron, you release it, and it doesn't stay a neutron for long, in minutes, and then this energy will communicate with another atom, and its energy will then revert to that of a proton. So, and what I was able to describe atoms in terms of just protons and neutrons, and each proton is at a particular energy level, whereas classically it's described as the electron being at that energy level, no, the protons at that energy level, and then when it jumps from one energy level to another, it is because it is communicating with the outside, increasing energy. It's receiving energy from another atom outside, and then when it gives up, when it transfers energy, it jumps back. That is the proton. When it becomes ionized, it's the whole atom, the whole proton is in communication with the outside world. So that's what we see as the electron. So effectively, what I'm saying is photons and electrons have no independent existence. All we have is the energy levels of protons. Also from that, I determine that we don't need a Higgs boson to give some particles mass and some not. I explain all that. So we don't need a Higgs particle. We don't need any of these particles. All we need are protons. And we have proton to proton communication. And then I looked at spin and quantization. Again, looked at it in terms of where protons are within the atom. And it can, spin and quantization can be described in terms of protons. That's it. I do hope you go back and have a look at the video. And then I described used the Schrödinger equation, and was able to show that the Schrödinger equation is a description of the wave function from an atom. So if it's going to communicate, if it has extra energy, then you have this wave function of the extra energy, and then its probability of finding another atom to communicate with, a receiving atom, and that's what the Schrödinger equation describes. There it is. Schrödinger equation is describing exactly what I'm saying about atom to atom communication and energy transfer. And then I looked at the measurement problem, and does the wave function break down? Yeah, of course it does, because the wave function describes the extra energy that a originating atom has, and it breaks down when it transfers that energy to a receiving atom. That's it. All of that's in the video. So measurement problems, and then I looked at protons, what they are not, and they are not quarks. They are not quarks. They are pieces of energy. Now, please, I got very few hits on what they are not, but it's very interesting to see, this up, down, colour in the quarks and everything. Don't need any of that to describe what's going on. And a quark, under high energy collisions, you supposedly can release a quark and then it's dragged back in by a gluon. Come on, I describe all that. This is just not it. If you accelerate a proton and you smash it into other protons, you will get energy being transferred in all directions, which looks like an up and down quark with a particular colour. Colour charge, but it dissipates. It's not pulled back into the atom. The whole thing then, eventually the energy is transferred to wherever else is in contact with it, and the whole thing then settles down into rest mass protons. And then I went on to the last video, which described what the proton actually is, and used this description. I really dislike this description of this depiction of gravity as this sort of distorted surface. It's not like that at all. But each proton then, and it's not just me saying this, every proton is at its nucleus a black hole. That's what we're looking at. And so when we've got a system of protons joined together in one way or another, and then we excite that. However, something can be done with light in the photoelectric effect, or you give it an electric charge. You're going to get charge flow, the flow of charge. Well, of course you are, because what we've got is black holes sitting, bumping up against each other's event horizons, and if we excite any one of them, there is a friction there, and that friction is, and that extra energy will be passed on to the next atom, and then the next, and then the next, and so you'll get this what's deemed as an electron flow. It isn't an electron flow, it's just energy transferring from one black hole to the next. That's it. So what I'm what I've called this video 10, Grand Unification and Gravity, the theory of everything. Now, Grand Unification is a theory which brings together electromagnetism, the strong and the weak forces. A theory of everything brings gravity into that. So far, Grand Unification has unified electromagnetism, the strong and the weak force, but cannot unify gravity. Now, what I'm saying is, this idea of mine has unified the whole thing. The electromagnetism I just spoke about, that's what it is. It is the transfer of energy within a system. That's what electromagnetism is. The last video on protons and what they are describes all that. The strong force is that which holds when you get protons combining together to make protons and neutrons combining together to make more composite, more complex atoms. Then the electromagnetic effect, the repulsion effect of electromagnetism is supposedly much stronger than that of gravity. But if you force them together closely enough, the constants of electromagnetism and gravity, they're unified to one. And then it's a very different story. Then push them in together and get them to effectively operate with no distance between them. So inside the Planck distance or whatever, then gravity comes into its own. Gravity is the strong force. We have the electromagnetism, the strong force, and then the weak force. The weak force supposedly drives separates pulls the more composite atoms apart. Now have a look at that. Uranium is, you may well know that it decays. Its decay chain, given enough time, will lead to lead. All stable lead in the world used to be uranium, and it decays by a whole series of events. I meant to put the chain in open. Okay. Here's the uranium. There's 92 let's say electrons, 92 protons. These are where all the protons are. 92 protons. And so it decays by a, there it is. I hope you can see this. There's uranium sitting there with 92 protons. It decays by releasing an alpha particle. Now, this atom is so cumbersome now that the energy level of these protons and their neutrons and their accompanying neutrons on the outside is so weak. It's so much more powerful in its energy, and it's so far away from the nucleus that eventually the repulsive electromagnetic force drives out an alpha particle, which is a helium atom, 2 protons, 2 neutrons. And we'll see this here it is. If you can see this uranium sitting, here we go, sitting here with 92 protons. It decays by an alpha particle. That's an alpha particle. So that it loses 2 neutrons, 2 protons into thorium. Now it won't sit there for long like that, just days, until that decays again. So what's happened is this system has been undermined. We've lost 2 protons and 2 neutrons, but now you see all these protons are all nice on the outside. Now you've got too many neutrons sitting here that are not actually tied up, and so it won't be long before one of them changes its energy with relations with the outside world. It's giving and receiving energy with the outside world. It won't do anything on its own. It will just sit there. It needs to be able to transfer energy to or receive energy from to make a change. Now, the change that it then makes is this beta change, where a neutron turns into a proton, and you've got this protactinium, which is the element that is very unstable, and another beta decay will occur, where another neutron turns into a proton. So we go back to uranium with 92. Uranium-234 with 92 protons, and then down the chain. An alpha particle takes it down to release of an alpha particle takes it down to thorium. Another, eventually alpha particle down through polonium into an unstable form of lead, beta decay, down into back to polonium, and so on, and eventually making its way to the stable form of lead. So we've come from uranium, whichever type it is, eventually to the stable form of lead. That's what's happening. So the strong force is simply gravity of the black holes working in the same space, and the weak force is where a let me draw on this. The weak force is, oops, that's not what I meant to do, that's what I meant to do, is where you then have this supposed up, down, down quarks of a neutron sitting in your complex atom, and it then communicates with the outside world, giving off an electron and a anti-neutrino, which supposedly doesn't really react to very much. It does react to certain things, but you've got to search hard to find one. And so this change of energy in this neutron turns it into a proton. And what they're saying is, here is a W boson that transfers the energy out to, takes that energy and then turns it into this. The W boson doesn't last very long. None of these subatomic particles last very long. In atomic terms, the W particle lasts a long time, but it's not that long. And I say, no, none of this. What you've got is this neutron in direct communication with some atom or the other, and this is an electron's worth of energy to it. You don't need the W boson to do this, and the fact is that this will either retain the little bit of antineutrino energy and try and transfer it to something or the other. Most atoms are not going to be interested in it, but some are, or it will transfer to this receiving atom, where this atom will then pass on this energy, but it may not pass on the antineutrino. It may still hold that little bit of extra energy, but a little bit of extra energy still exists, and this particle will then look and come across other particles all over the place, but they won't be interested in taking that little bit of neutrino energy. So it's saying, it passes through these until eventually it can find something. And if you want to see how a neutrino is detected, you can look that up online. But again, none of these particles exist independently. This keeps happening until we reach a stable position, and that of stable lead, where all the protons and neutrons are all nicely interlinked with each other, all settled down, and it's not going to want to transfer any energy to the outside world or receive any energy from the outside world. It's stable. And that's what's happening. We're talking to energy transfers between what? Between protons. That's it. The whole thing. This is all these protons here, all with their accompanying neutrons. That's what this atom is made up of. Lead is made up of, and it's stable. So that, what do we have? Now, let me come back to to here. Grand unification. I've shown that what electromagnetism is, the way it is the transfer of energy, photons or electrons, between protons. Photons and electrons. Electromagnetism, a strong force, is gravity. It's the gravity of two black holes existing in the same place. The weak force is, you see, cumbersome atoms that cannot hold together, that transfer when they come in contact with other atoms outside of themselves. Then energy is transferred, and you'll get release of an alpha particle, effectively a helium particle with a release of energy, which is why it's so dangerous, it's radioactive. Or then you'll get effectively too many neutrons left that are not tied into the network of protons and neutrons effectively enough, and so they will transfer, emit or receive energy from the outside world, and that neutron turns into a proton. It can happen the other way around under certain circumstances, but you can look that up. But that's what I'm saying. So electromagnetism, strong, weak force, are all effects of the energy levels of atoms, which consist of protons, which are tiny black holes. Effectively, everything is proton. Everything is a black hole. And a black hole essentially is gravity. What we have is not a unified system without gravity. What we have is gravity causing all the other effects. The gravity of the black holes, which are protons and neutrons, the gravity of those black holes is causing all those other effects. That's it. So instead of gravity sitting outside of unification for a theory of everything, gravity is the theory of everything. And a black hole, a proton, cannot exist of itself. If you have one in the universe, how could you measure its energy? You can't. It doesn't exist. It can only exist with respect to another black hole, another atom, another proton. And that's what we have. Everything is protons. Everything is gravity, and the effects of the energy, the change in gravitational effect of those protons. It's a theory of everything, an absolute relativity. There it is. I don't think I can say any more about it. I will be saying more in these kind of appendix videos, but these 10 videos lead to this definition, new description of quantum mechanics, of quantum physics. And that's it. I'm going to leave it there. It is a theory of everything. And I'd like to say about it that Occam's razor suggests that if you have two descriptions of a phenomenon, then the simpler is likely to be the most accurate. And this description is infinitely simpler than what we have with in quantum mechanics as it stands. Infinitely simpler. So I say, apply Occam's razor to this. And this is a simple theory of everything. That's it. I hope you will still follow the videos as I go along and do these appendix videos. The first one I'm going to do is I'm going to be talking more in depth about the many worlds theory. So this wraps it up. An Absolute Relativity. I hope you've done the whole journey and enjoyed it. So thank you very much for joining me here, and I'll say goodbye.